All right, so last class we talked about what trigonometry is. We talked about how to label the different angles, and we also learned how to find side lengths. Okay, so just to begin our trig stuff, let's go ahead and review everything we know. What exactly is trigonometry? It's basically a way for us to study the relationships between the angles of a triangle and the side lengths. That's the most simplest way to describe trigonometry. So we're only going to be looking at right angles because we're not going to have time to look at any other different triangles. The first thing you should know is when you're labeling a triangle, you use capital letters to label the angles. So for example, I can call this angle A, I can call this angle B, and I can call this angle C. So whenever you see capital letters, I'm talking about the angles. If I want to label the side lengths, I use little letters and I just go opposite. So opposite of angle A, this would be side length A. Opposite of angle B, this would be side length B. And opposite of angle C, this would be side length C. That's just like the basics of how to label a triangle. Another way to label a triangle, if you didn't want to call it angle C, let's say we didn't have these letters, you could also use a Greek letter or any symbol to represent an angle. I could use a dot, I could use a heart, a smiley face. Most often though, we use the letter theta. And theta is just a Greek alphabet used to represent an angle that we're trying to figure out. Now, according to this angle, we're going to label all of our side lengths. So the hypotenuse, which I call H, is always across from the right angle. And then according to this angle, whatever side length is close to it without it being the hypotenuse is known as the adjacent. And right across from the angle is opposite. And that's super important because that's really everything we need to know when we're trying to solve these angle questions. So basically, a long time ago, people were studying triangles and they're like, well, what is the relationship between an angle and all the side lengths? And they noticed that there were actually patterns that emerged. So you could take an angle and you could divide two of the side lengths and they would notice that you would get some sort of answer. And basically, they used to make these huge sine, cosine, tangent charts. So before calculators, people would actually measure out all of the triangles, divide the numbers, and then write it down in a chart. So they would say, when this angle is 20 degrees, then the ratio of the sides is going to be whatever it is. If this angle is 21 degrees, this is what the ratio will be, 22 degrees. And so back in the day, mathematicians would have like these massive tables of all of these different ratios. And then obviously the calculator was invented and then they programmed all of the stuff into the calculator. So now all we need to do is press a button and then the ratio comes up. That's basically what we're doing. We're taking information and plugging it in and solving. So in yesterday's class, we learned a really important acronym, which is called SOHCAHTOA. And this is what we use to solve any right angle triangle. Okay, so this tells me the sine of an angle is equal to opposite over hypotenuse. This tells me the cosine of an angle is equal to the adjacent over hypotenuse. And this tells me the tan of an angle is equal to opposite over adjacent. And as long as you remember these formulas, then you can basically solve any question. In yesterday's class, I gave you all of the angles. So for every question we did, the angle was given, you were trying to find the side length. In today's class, every single question, we're actually going to be trying to figure out what the theta is. So I'm going to give you the side lengths and I'm going to ask you what theta is. So it's the finding angles lesson. But nothing changes. We're still using exactly the same formulas and the same process. There's just one extra step we're going to have to do for every single question, which is where your calculator becomes really important. Can you solve these questions without a calculator? No. If you don't have a calculator, there's no way for us to solve it. So you absolutely have to have a calculator. Isn't it funny how like from September, we're like, no calculators, no calculators. And now we're like, if you don't have a calculator, you cannot do this. And honestly, in RH King math, the only time you really are going to use a calculator is for the trig unit. So when you get to grade 11, again, be prepared for, it really depends on the teacher as well. Like some teachers are okay with it, but usually the first couple of units, we try to get you to not use a calculator so you can use your brains and get really good at multiplying, dividing, etc. And then when we get to the trig unit, of course, calculators are allowed. Okay, so how are we going to do this? let's take a look at the notes. It says, if you know the sine, cosine, and tangent of any angle, you can use the inverse of the ratio, sine inverse, cosine inverse, tan inverse, to find the measure of the angle. So that leads us to a very, very important rule, and that is we are trying to find the angle of anything, not angel, angle. Here are the buttons we need to find on our calculator. So find the button on your calculator that has the little -1 sign. Okay, sorry, we're back. So we're gonna try to find the button that says sine inverse, and then we're gonna try to find the button that says cosine inverse and tan inverse. It really angers me when the little square doesn't become like a perfect square, because sometimes it does and sometimes it doesn't. Look, watch this. It didn't again. Maybe now it will. Okay, whatever, I failed. All right, I think we've all found the button, so let's see how we're going to use it. So question number, and by the way, make sure your calculator is in degree modes as well. So remember how yesterday we were changing it to DEG? Question number 1, we have a triangle. We're trying to figure out what the X is. And just like before, we're going to go ahead and label all of the side lengths. So according to this angle, this is opposite, this is the hypotenuse, and this is adjacent. Hopefully from last class, we do remember the strategy we use. I just look at what information is given or not given, and I eliminate what I can't use. So because in this question, there is no adjacent side length, what trig ratio do I have to use? Yep, sine, yeah. So we're gonna go ahead and write our formula, which is sine theta. I'm just gonna scroll out a little bit. It's just too chunky. So sine theta is equal to opposite over hypotenuse. We're going to put in the information we know. We don't know what theta is. They've labeled it X. You can label it X or you can keep it as theta. But we do know the opposite side length, it's 15. We do know the hypotenuse, it's 24. All right, so how exactly are we going to solve this? This is what you're going to do. Now, you don't need to write this step. I'm just going to write it a couple of times for you to get used to it. In order to figure out the angle, we are going to take the sine inverse of 15 over 24. So in your calculator, you're going to click sine inverse. I would keep it in brackets. So I would say sine inverse bracket 15 divided by 24, close bracket, and then solve it that way. And just like yesterday's class, we'll round to 2 decimal places. What do you guys get when you do that? Okay, not what I got. Tell me if you got something different, Brianna. That's more what I got. So Sophia, just check your work again. I got 38.68 degrees. I'll pause here. So you guys. Question number 2 says, again, we have X. Let's go ahead and label all of the side lengths according to this angle. So, excuse me, this is opposite, this is adjacent, and this is the hypotenuse. What do you guys think we're going to use, sine, cos, or tan? What was that? Cosine, yeah. Sorry, that HEPA filter is so loud, I don't think I can hear much. Cos theta is equal to adjacent over hypotenuse. The reason we use cosine is because the opposite side length is not given to us, so we can't use sine, we can't use tan. They both have opposite. The only thing we can use is cosine. We're going to put in the information that's given to us. So cos theta is equal to 8 over 11. And in order for us to figure out the angle, theta, we're gonna, in our calculators, go cos inverse 8/11. I didn't get 46, close, but that's not exactly what I got. That's what I got as well. So 43.34 degrees is the answer. Okay, so there are about 6 questions like this. We'll do 2 more together, then I'll give you a chance to do 2 on your own. Did you do 8 divided by 11, then did you click the equal sign? Do it again. 8 divided by 11, equal sign, second function, and then cos. Yeah. Brianna? Yeah, of course. Okay, so see how when I have an angle here, the angle opposite, the side length opposite of the right angle is the hypotenuse. The side length opposite of the angle is the opposite, and then the closest one is adjacent. So do you see how the adjacent is equal to 8 and the hypotenuse is equal to 11, but there's no opposite side length. So because there's no O, we can't use this and we can't use this. Both of those have an O in them, so we have to use the cosine. All right, question number 3. We are going to label all of our side lengths. So we have hypotenuse there, we have opposite there, we have adjacent there. What do you guys think we're going to use for this? Sine, cos, or tan? Tan is correct. And the reason we use tan is because there is no hypotenuse side length given to us. You guys, here's something interesting though. If we have 2 side lengths, can we figure out the third side length if it's a right angle triangle? We could, right? We could use Pythagorean theorem and figure it out. And then if we have all 3 side lengths, what do we use? Sine, cos, or tan? We can use any one of them. So I explain what I mean. If I gave you a triangle and I said, this is 3, this is, sorry, that's not possible. This is 4 and this is 5. And I'm asking you for that angle. You can use sine theta, you can use cos theta, you can use tan theta. It doesn't matter. You're always going to get the same angle because you have all of the side lengths. However, in these questions, I've only given you 2 side lengths. It's too much work to use the Pythagorean theorem, figure out the hypotenuse. You can use tan and still get the same answer. So why go through all that trouble? Okay, so tan theta is what we're trying to find. Opposite is 20/37. This is going to be tan inverse of 20/37. You guys may have already got the answer. What'd you guys get? 28.39 degrees is correct. You got something different? Sorry, I thought I heard someone say they got something different. Okay, go ahead and try 4, 5, and 6 yourselves, and I will put them up on the board. Shweta? All right, so for question 4, we got 38.50. Question 5, we got 77.32. And question 6, we got 54.46. Now, just so we don't forget what we did last class, because it can get confusing what you're trying to do, we're going to review how to find the side lengths. Maybe we won't do all of them because it might be a little overkill. Let's just go ahead and do questions 9 and 10. Just to review how we did things yesterday. So in question number 9, you're going to notice that we have this is the opposite side length, adjacent, and this is the hypotenuse. So we know we're using tan. We're going to write tan theta is equal to opposite over adjacent. And this time the angle was given to us. And whenever the angle is given to us, that's where we put it into our theta. So this is going to be tan of 51 is equal to 8/x. And remember, we did 2 steps for this. First, we multiplied the x over here, and then we moved the tan 51 to the other side. So I know last class we were showing all of our work. I think for this class, I'm just going to show you what that would end up looking like. It would just be 8/tan 51. Now, if I'm writing tan 51, do I have to use that inverse button? No, you're just going to type in tan 51 exactly as you see it. The only time you use the inverse button is when you're trying to find the angle. But they gave us the angle of this question. So we definitely don't need to use the inverse. And what did you guys get as your answer? Remember, this is a side length, so we won't put the little degree sign. What'd you get? 9 point. I didn't get that. Someone get something other than 9.88? Yeah. Yeah, so just check again. You might have clicked something else. I also got 6.48 for my side length. All right, we'll do one more just to complete this section. Let's do this one. So according to this angle, this is opposite. This is the hypotenuse. So we're using sine. Sine theta is equal to opposite over hypotenuse. Sine 24 is equal to x over 31. And when the x is at the top, it's actually very straightforward because all we're going to do is multiply 31 times sine 24. And we end up getting 12.61. All right, so for question 15, it looks a little difficult because there are two triangles. But really, if you break it down, you're basically just solving one triangle to help you figure out information for the other triangle. What is our ultimate goal? Our ultimate goal in this question is to find side length DE. So we are trying to figure out this side length over here, which they've called DE. If you wanted, you could just call it side length X or Y or anything, however you want to label it, it's fine. Now, unfortunately, in this triangle at the bottom over here, we don't have enough information. All we know is this is angle 19, but we don't know any of the other side lengths. So we're going to have to go to the triangle at the top to first figure out which side length. So what side length should we figure out in the triangle at the top? CF, CD, or FD? Yeah, we definitely need to find FD. And I'm going to go ahead and just, you know what, I'm not going to use the letter X just to not be confusing. I will go ahead and find this one first. That's too close. So let's use this. Okay, so we're going to first go ahead and find this side length, which is FD. So ignore the triangle at the bottom. Just look at the triangle at the top. If we have 61 degrees, this is going to be the opposite side length. This will be adjacent, and this will be the hypotenuse. What do you think we're going to use, sine, cosine, or tan for this question? We're trying to find the opposite side length. Yeah, we're going to use tan. So we're going to say tan theta is equal to opposite over adjacent. We know what theta is in this question. It's tan 61 is equal to, we don't know the opposite side length. And in fact, the opposite side length has, we'll just use the method they've used, use the alphabet. So DF over the adjacent side length is 24. You could have labeled DF like the letter Y or something, but because they've used DE in the question, I'm going to just be consistent and keep it as that. And then to find side length DF, you're just going to go ahead and move the 24 over to the other side, and it's going to be 24 times tan 61. And I think I mentioned this last time, but when you have a question, anytime in math, when you're doing a question that requires multiple calculations, like you need an answer to carry on to the next answer, don't ever round your answer until the very end. This is especially important when you get to physics. So for this question, I'm finding DF, but that's not my final answer. I need that DF to go to my next triangle. So I'm actually going to keep as many decimals as I can, so that my answer can be as accurate as possible. Okay, so there's no rule to how many you should keep. The only rule is don't round it. Because if you round it, then the answer becomes too it becomes less accurate. Did you guys get about 43.29 for this though? Okay, great. Now we're going to move on to the next triangle, and we're going to try to figure out what DE is. So according to this triangle, if that's angle 19, then this is opposite, this is adjacent, and this is the hypotenuse. We have the adjacent side length. We're trying to find the opposite side length. So what are we going to use? Sine, cos, or tan? Yeah, we're going to use tan again. And for this triangle, we know that the theta is 19. We don't know what the opposite side length is, but it has the letters D and E. We know the adjacent side length. We just found it in the previous question, and it was 43.29714. So now to calculate what DE is, we're just going to multiply those two numbers. And I didn't even erase my calculator, so all I need to do is times tan 19 to give me my final answer. What did you guys get for your final answer? And now we can round it. 14.91? Yeah, 14.91 units. Zutelor. Also, why did it make the letter D so? Okay, whatever. Hi. We're learning and recording. Take it. All right, go ahead and do 16. We'll take it up, and then we'll do one of the word problems. So I didn't record question 16, but there's a solution. It just required us to use sine to find the side length, and then use tan inverse to find angle D. All right, applications, remember, we're just drawing a picture and then using the picture to figure out what's happening. So they're usually like ladders and kites and ramps and things like that, anything to give you a right angle triangle. So just like before, a ladder is leaning against a wall. Let's draw that. So let's say that this is our wall. And then we have a ladder leaning against it. And then there's the ground. A ladder leaning against a wall makes an angle of 75 degrees with the ground. So that means that the angle right over here is going to be 75 degrees. If the foot of the ladder is 6 feet from the base of the wall, which means I just need to move this up a little bit so I can write that number in. So if the foot of the ladder is 6 feet from the base of the wall, which means there's 6 feet here and here, what is the length of the ladder? All right, so let's label this diagram according to what they have given us. We have the hypotenuse, which is right here, and then this is the adjacent side length. So are we going to be using sine, cos, or tan for this question? We're going to be using cosine. By the way, it is a word problem, so we should be defining our variables. So our let statement is going to be let x represent the length of the ladder. And then we're going to use cos theta is equal to adjacent over hypotenuse. They've given us the angle, so it's going to be cos 75 is equal to 6 over x. And then x is just going to be equal to 6 over cos 75. We don't need to use cos inverse for this, as they have already given us the angle. And remember, if it is a word problem, you're probably going to have specific units. So in this case, I got 23.18 feet. And then you would have a therefore statement that said, I'll just put dots so you guys can fill that in. Therefore, the length of the ladder is 23.18 feet. Okay, last question. Jaden is flying a kite and lets off 275 feet of string. Kite flying is so much fun, and I just feel like people here don't do it enough. Do you guys feel like people fly kites often anymore? They really don't. But if you go to like Asian countries, kite flying is such a big thing. They have like kite challenges and fights and stuff like that. We need to bring that over here because that's really a lot of fun. Jaden is flying a kite and lets off 275 feet of string. So let's draw Jaden. And then smiley face. If the kite is 150 feet off the ground, let's draw the kite. There we go. And so we can tell, now it's not going to be very accurate because they've told us that this kite is 150 feet above the ground. And we're kind of assuming that I did draw Jaden, but really we're going to assume that that string goes all the way to the bottom of the ground. So it's going to be 275 feet. So not the most accurate diagram. Because obviously when you're holding a kite, you're not holding it from the bottom of the ground, but I guess we're just going to have to pretend a little bit. So Jaden is like here, the kite string is 275 feet. The kite is 100 feet above the ground. What angle does the string make with the ground? So they're trying to ask us what this theta right over here is. Okay, so if this is opposite and this is the hypotenuse, we're going to be using sine. So we're going to say sine. First, we're going to have a let statement. So we're going to say let x represent angle the string makes. I guess that's kind of accurate enough. Then we're going to say sine theta hey. Yeah, of course. Oh, I see what you're saying. Yeah, of course. I see what you're saying. I used theta and I didn't use an x over here. You're right. Okay, so let's go ahead and use x there. All right, now we can go ahead and solve this. So it's going to be sine theta is equal to opposite over hypotenuse. Sine theta is going to be equal to 150 over 275. And then theta will just be sine inverse of that. So it's going to be 150 divided by 275, which will be 33.06 degrees. And then you guys can finish it off with therefore statement. Therefore, the angle the string makes with the ground is 33.06 degrees. Oh my gosh, look at the timing, you guys. Tell me that's not impeccable. That's pretty good, right? So we're going to take a 20-minute break now. When we come back, your homework and classwork is going to be this page and this page. Solutions are there. And then this is going to be the thing that's included on your test. I'm just going to stop the recording so I can tell you about the test.